Hi, everyone. Welcome to the CAEP deep dive session. And we'll promise to keep it entertaining, maybe not as much as the party after, but we'll try, right? So welcome, everyone. And we are here to discuss CAEP. And my name is Atul Tulshibagwale. I'm CTO of a company called Signal, SGNL.ai. We are into access management, just-in-time access management.
Hey, I'm Tim Cappalli. I'm a standards architect at Microsoft. Hopefully you know what Microsoft is. So.
Yeah.
And we're also co-chairs of the Shared Signals Working Group at OpenID.
Yep. Just by way of agenda, we're going to talk about the problem. We're going to talk about just how the standard works in general, and get into some of the details of the flows, and then we have a special demo of a website that acts as a CAEP transmitter, and then we'll jump into the use cases, the specific use cases that might be of interest to you. So what we are, with CAEP, what we are trying to solve is basically a problem that everyone faces, which is the zero trust security problem. What that is that, users are simultaneously logged into, hundreds of services, but the information that affects those services is localized in many different places, and there are many different sources of truth. So you may have a device compliance service, right? That basically says, each device that is being used to access your corporate resources needs to check in every couple of hours, make sure it has all the right updates and things like that. But maybe a device fails to check in. Now the device compliance service knows something about the posture of that device, but it has no way to communicate it, right? Or an identity provider may know that, hey, your credentials have changed, or your MFA has expired, or something is different about you than it was when you had actually logged in, right? Your access properties may have changed. You may have switched roles. You may be now working on something different than before. All that needs to be communicated. And finally, there are people scanning the dark web, and they find your credentials on the dark web. Now that needs to be conveyed to everyone else as well, right? So there can be more cases like this, but basically this is the problem, that all these independent sources of truth need to come together, talk to each other in order for us to give us a good security outcome, right? And so what SSF and CAEP basically do is the Shared Signals Framework provides a asynchronous publish and subscribe mechanism. It gives you a very good way of negotiating what somebody is willing to disclose about users and what somebody wants to know about those users, right? And then the CAEP part, the continuous access evaluation profile part of it, talks about specifically events that affect the session properties, right? And in how does it affect the zero trust security, right? So basically, any enterprise is going to have software from multiple vendors, right? So it's going to be impossible to find anyone who just has everything from one vendor, or a group of vendors who have agreed to work together by calling each other as APIs. You need an open standard in order to be able to deliver the security outcome of zero trust, right? And so what SSF basically does is provides a framework that is very flexible. It conveys all the information that is needed that affects session security to where it is needed, and it is efficient. So it is, it doesn't mean you have to keep polling things or something like that. Whenever there is an event, you'll know about it in a reasonable amount of time, not exactly in real time, but very close, right? And it is non-prescriptive. So when an event gets sent, there is no expectation that the recipient is going to take a certain action. And that's very important, because that makes the connectivity much easier, because then the trust between those parties doesn't have to be to a level which you can expect only to be within a company, or even there it might not be possible. So over to Tim.
Thanks. Yeah, and just to dive into these, they're specs, right? But to dive into how they actually work and what's in them. The Shared Signals Framework you can think of as kind of the core, right? So it's really where we deal with all the management. How do you actually subscribe to an event? What type of method do you want to actually use? Do you want to get the event? Do you want to, you want to query for them? Do you want to send them in a webhook style? It defines, essentially the security event token, which comes from IETF actually, but it's actually a profile of JOTS, and it says how you should treat that in this framework, right? Everything's about your context and how you see it in that context. And if we think about those as management and transport, the other two specs that we currently have, we can think of as dictionaries, right? They are normal specifications in OpenID, but they're really just, they could be registries, and maybe that's the long-term solution. We should make them a registry. But we can think of RISC, which has been around for quite some time. You may have actually remembered this all was called RISC at one point, if you've been following the space for a while. We've evolved it. And that's really your account-related events, right? So you can imagine Google and Microsoft, right? You sign up for a Google account using an email from Outlook.com. Maybe it's good that we know that the account was compromised, right? Because you're sending emails to that. Maybe it's used for recovery. So it's really those account-centric events. The common for are a credential change was required, the credentials were compromised, the account is paused, or the account is enabled, right? Account enabled and paused are very, very common and often flip-flop, and it's important to send that context. The new piece that Atul had started to explain was the CAEP, right? The Continuous Access Evaluation Profile. Those are those zero trust session management events. And the three most popular ones that I think we spend the most time discussing and tweaking and changing are session revoked, token claims changed, and assurance level change. There's more than that, but those are the top three. And the reason we want to highlight how all these come together is it's super easy for us to add a new use case, right? If we just keep adding at the top, they all work within the shared signals framework. And the other nice thing is the spec is open so that if you have a relationship between two organizations, you can use your own events. You don't have to register them, right? Which you could do that anyway. Obviously, no one's going to tattle on you, but we actually leave it open. But we really hope we can get to a point, I think looking back on 4 or 5 years worth of work now, we don't want to have to go through an entire standards process to add just a JSON dictionary, right? Like we need to be able to do that quicker. So we're working with the OpenID Foundation to say, we had a financial use case. We don't want to have to take a financial organization that has a really awesome use case through the standards process. If you're involved in that, it's not slow, right? So we can find a way to make this more extensible. But I just wanted to kind of highlight these different components and how they relate, because we often use SSF and CAEP interchangeably. CAEP, for better or worse, has the better industry name recognition, but it's really the dictionary of zero trust events versus the account-related events. If we look at how all this works, right, so looking at SSF, right, the core protocol, everything is bound to a stream, right? So if you as a receiver, you essentially say, I would like to request a certain set of events, create me a stream, and I'm going to actually tell you how I want to receive them, right? I'm going to poll. I can do a get, or I can actually set up an endpoint where they can be sent to me in very much like a webhook, right? It's kind of a more formalized version of a webhook. And there's also some verification events, right? You can imagine some of these relationships using Microsoft and Google. Theoretically, these relationships could exist for years, right? Because there's millions of accounts, and so being able to actually check that stream is still active is super important. So if we actually step through what this exchange looks like. The receiver says, hey, I want to create a stream. The transmitter, assuming they're capable, start to send events, right? And obviously that first step is there's a lot more that goes on. We'll talk about that in a second. But ultimately, in the case of push, right, so a webhook style, the transmitter sends events as they occur, right? It may be once, it may be never, it could be 100 times a second. The other approach would be poll, right? Depending on your architecture, your scale, global scale, I'm sure everyone's aware of these different patterns. You may actually want to just query periodically once per hour and say, hey, do you have any new events, right? So long polls versus push. And at that point, right, we can actually also change the stream, right? So the transmitter may say, hey, authorization's changed. You're abusing these events. We want to pause your stream, right? So you can start to see all these different management flows that are required beyond just the events themselves. And in that case, the receiver would pause or restart the stream, and the receiver can also start to request verification events. So that's a very, very simplified version of all this. Obviously, the life cycle of these streams, as I mentioned, can be years, but this is kind of a quick high level there. So how do we actually convey information in these events, right? So we mentioned these events are based on security event tokens. Subjects are the most important things in identity events, right? So one of the major changes we made as this work progressed from what was just RISC to this new framework is making subjects a lot more flexible, right? So we kind of have the very basic simple subject, the thing everyone's familiar with, email address, phone number, or some unique identifier between your parties. The subclaim is a great example. That should be unique for that relationship. But what we added was this idea of a complex subject. Using Microsoft as an example, right? We have users, we have tenants, we have devices, we have sessions, right? We need a way to convey much more specific information in a standardized way with a specific format, right? Being able to say that this user identifier I'm going to send you is in the format of email, and it's actually also only this user in this tenant, right? Because as we start to look at these cloud-native solutions, my email address, tim.cappalli@microsoft.com, could exist in 100 tenants in a B2C use case or a B2B use case. So if we dive into what those actually mean, right? So specific subjects can be added independently to each stream. So we actually, the original version of this only supported a single stream per relationship. But what we found is there are cases where the transmitter and the receiver have a common, essentially front-end proxy, and they need to send events to different parties in the back-end at a large scale. So being able to actually say this stream goes here makes routing much easier, right? It's also for data compliance. You may not want to send certain subjects to certain countries depending on region, right? You may have a data center in Europe, and you only want to send these events to a US data center, right? So the streams allow you to be super flexible and say at a very granular level or a very high level what events you want to send there. The subject value can be one principal, but it may be coarse grained or fine grained. You should never be, you should always be talking about the specific principal when you include multiple attributes. And I'm going to skip actually over to that example. Oh, sorry, I thought I had a diagram. So if you look at that on the left-hand side here, right? So I'll use the Microsoft use case, right? I want to say revoke this session on this for this specific user on this specific device in this specific tenant, right? That's probably the most extreme example of what you could do. But you could also just say, I want to subscribe to all revocation events for the tenant target.com, right? Like that, it could be that wide or that specific. And that's what's really flexible about it. And we didn't have that before we kind of did this V2 work on shared signals. It was very, very much bound. It was literally bound to a token and what the token was allowed to do. And that was the flexibility. That was it. So we think this provides a lot of flexibility. The nice thing is a lot of this isn't reinvented. We're profiling a lot of existing work at IETF, the subject identifiers work, and essentially pulling it together into a semantic meaning for these events.
I'll use the keyboard because
I'm
going to need a mouse. So I'm going to jump into a little bit of a demo, right? So what this demo is going to show you is a website called cape.dev. It's something that all of you can access. What it provides you is a CAEP transmitter. And the purpose of this demo and this talk is to show you how easy it is to set up a CAEP transmitter, set up a CAEP receiver, and start exchanging events between them, right? So let's jump into the website here. This is cape.dev. This is sponsored by my company Signal. And it has, before I start transmitting events, it has a learning section. You can sort of have an instant recipe of how to do things and things like that. But also, then it has a transmitter that allows you to transmit events.
Where's that coming?
I don't think it was.
Okay.
Because the first thing it needs is an access token. I don't have an access token with me, so I'm going to register myself. And so I'm going to say I'm Atul, and I'm not a robot, and I'm going to register. And what it'll do is it'll send me an email with the registration information. So I'm going to jump into my email quickly, and this is the registration URL, like the confirmation URL. I'm going to confirm, and I'm going to enter some little information about my company and this last receiver URL is just something that the protocol requires as a unique identifier for the receiver, right? It can be anything. And so I'm going to complete my registration, and now I'm going to get an access token. So I'm going to download this access token, and here it is. So I'm going to see this access token. I'm just going to copy it into my clipboard so that I don't have to type it in. And so now I'm ready to transmit events, right? But who am I transmitting to? There's no receiver. I've not set up a receiver, right? So what I can do is I can actually download a Postman collection. Now, I'm sure all of you have used something like Postman, which is a way to just exercise, API calls. So I'm going to download this Postman collection, which is going to be my receiver, right? And here's the Postman collection. I'm going to just import it into my Postman. So downloads. Yeah, this one. So as you can see in this Postman collection, there are just two things, right? There's a method to create the stream, and there's a method to poll for CAEP events, right? So I'm going to create the stream. I need to enter the authorization header. So I just put my access token in here, and now I send this request, which basically will create a stream, right? There you go. And I've created a stream, and I've got the response, which is the stream ID and all that. So what I'm now able to do is I'm able to send events to my receiver, right? I'm going to go back to the transmitter. It's already pasted in my access token. I'm going to send an access, session revoked event, and for some reason I want to revoke the session of this user called Atul at signal.ai, right? And I'm not a robot, and I'll send this CAEP event. And so now this event has been queued for sending, right? And I can in the logs I can see the transmitter log that a few seconds ago that event was generated. Now when I actually go to the receiver, I can poll for that event. So if I paste in the access token for authorization, and I will be able to poll for that event. And here you go. This is the event that comes back. And if I there's sort of the value that I get from the event, I'm going to go to jwt.io and parse it. Let's see. Okay, and you can see that this event has come to me with my receiver. So in 5 minutes, I showed you exactly how a transmitter and a receiver can work together. So it's an extremely simple protocol that can give you a lot of value in the end. Right? So let's go back to the presentation. All right.
Yeah, so I'm going to talk about the session revocation use case, and then Atul is going to take the rest of the way. The reason I want to talk about this is actually what we're using internally at Microsoft, right? So between all of your M365 services, we're actually sending this CAEP event to revoke your session. So if you're familiar with continuous access evaluation, which is the Microsoft feature name, that's actually what we're doing internally, right? So we're using all of this. And the idea here, right, is the user begins a federated session with the service provider using a login from the IDP. In our case, this is all first party, but we still have an IDP, login.microsoft.com, and we still have the resource office.com. At that point, the service provider says, hey, I want to add this user to a stream. So this is the more specific case where you're not saying, I want all events. You're saying, maybe this user accessed a very high-risk application, and I want to know if something changes so I can immediately revoke access, versus the user accessing their own files, or let's say a low-risk application like their own HR data, right? Sometimes that's less risky than corporate data. So in this case, they will create a stream if it doesn't exist. The service provider could also just add a stream to a new subject to the existing stream if needed. Something goes wrong. The example we've always used is the user's in a coffee shop or something. They go onto an untrusted network. Let's terminate the user session. And the IDP simply sends essentially the event that Atul just showed, which is session revoked with the subject. In this case, it's probably going to be the subclaim of the ID token from the auth session or an email address. Again, it could be down to even the device if you wanted it to. And at that point, the service provider will take some kind of corrective action. Because these are just signals, right? The service provider may say, hey, we don't actually think this is a big deal. The information they're accessing isn't a big deal. We're not going to do anything. In our case, we send, in our deployment, we always send the user back to the IDP so we can reevaluate conditional access and all that fun stuff. So super flexible, probably the largest scale event just because sessions are constantly being revoked. It is also one that we're really starting to think about in the context of third-party cookie deprecation and things like OpenID front channel logout going away. Could this be one of the solutions? And we think maybe. We're not quite sure yet at scale. But.
Definitely the largest scale CAEP event that is being sent around today, and because bunch of risk events that the Google service sends. So
yeah, and I don't know the exact number. We're sending in the order of 50+ million events per week for session revocations.
Yeah. So let's take a look at a use case where it's not just between the identity provider and the service provider, right? So you may have a device management service, and the device management service may expect a corporate device to check in regularly, right? So the device management service acts as an SSF transmitter, and the identity provider in this case is the SSF receiver, right? Because it's interested in knowing whether the devices that are being used to sign into various corporate services are managed or not, right? And so if the user's device falls out of compliance, now this could be that simply the device failed to check in, or they are not up to date on their patches, or something else has gone wrong. And so the corporate policy has now decided that, well, this device is no longer compliant. So what happens is now there's a CAEP event called device compliance change. Now that gets sent to the identity provider using SSF, right? And then the subject of the event is an identifier that is known to both. So it could be a device identifier that is known to both, or it could be the email address of the user as well, right? And then once the IDP receives that event, the IDP can take corrective action, and that corrective action could mean sending a whole bunch of CAEP events to other providers, like your session service providers, right? So that's sort of the device management use case.
And one thing I just want to call out, you'll notice like send a session revocation, and we just talked about session revocation. Yeah. I think this is a great example of, depending on what party you are in the mix, you may want more of a direct signal that the session was revoked based on policy, or you may just want to receive this context to then make your own decision that the session was revoked. So you can imagine multiple parties sending different events depending on their view of the world, right? Not everyone has their IDP as the policy engine. A lot of applications have their own policy engine, right? So there's a lot of flexibility in what you're sending and what it means depending on who you are.
Yep. And finally, let's look at the authorization use case. This is close to my heart because our company is all about access management and authorization, right? So in authorization, let's say a service provider is acting as a SSF receiver, and it accepts resource identifiers that the user has access to when the user gets logged in, right? These could be in the form of attribute tags, or it could be explicit, identifiers of specific resources like files or buckets or whatnot. It could be, right? But let's say the identity provider now decides that the user needs to have a different set of resources that the user should have access to. So what it can do is it can send a token claims change event, right? The token claims change event can say, now these are the new claims. Now, because you want the API to be restful and not having state, you have to sort of include all the new resource identifiers that the user has access to. And so now the existing claims that were sent during the federation session establishment can be replaced with these new resource identifiers, right? And that way now the user has access to a different set of things than before, right? And so the SP can accordingly adjust the user's access pattern.
Yeah, the token claims change we added because we think it's the most flexible, right? If you can imagine a world where I come from a network security background, so the idea that we use IP addresses still for authorization blows my mind, but it is what it is. The idea that the user's IP address could change, and that's not important for the issuance of this token that was given to you to start the session, but it may be important to the SP, and to issue another access token or ID token just to change that value might not make sense because you don't necessarily know if the other parties are using it. You can also send it in the opposite direction, right? The other resource, let's say a file sharing service, they have a different lens on the world than the IDP did, so they can actually say, hey, the claim that you sent in your token, we're going to send back in the opposite direction and say, this changed from our lens, right? So it also brings a full 360 view from both the application, the service provider, and the IDP.
Yeah, great. And so finally, you can explore these standards at the OpenID Shared Signals website. There's a great resource from Cisco called sharedsignals.guide. Give you a great introduction to the standard and as well as some open source. And then I showed you cape.dev. Go to cape.dev, play around with the standard. You'll be amazed at how simple it is and how powerful it is. That's it from us. Any questions?
Yeah. We didn't even time that, and we were on time. Yes.
Yeah.
We could probably, well, if you want to go get beers, I won't blame you, but we could take some questions. Yeah. That's a good question, and honestly, probably something as the working group chairs we could do better at. Maybe we need to create some, if the passkeys.dev stuff highlights how to do passkeys, maybe we need one that actually tracks CAEP implementations, SSF. So we'll take that as feedback. That's a great. I'll say go to the OpenID working group page, and that's where everything links. Maybe we can get something out of there. That's a great call. Thank you.
Yep.
This is great because it's identifier based. This is great for account based exploitation. Is there a way I can leverage this for like trying to detect scalable fraud? People use shaky devices attacking a lot of things, but they don't necessarily have stable identifier. How do we sort of leverage that sort of signal? Maybe people are seeing API addresses are acting weird. That case maybe, but there's other way people continue to fake their IP addresses, continue to attack a lot of different sites.
Yeah, that sounds like a great example of maybe that's a new profile of events that we would create, and that would give you the semantic meaning of how to define a subject in that case. So I don't think we have one specifically for that right now, but the nice thing is we could add an event. It's just a JSON object, and
they won't have a stable identifier, so I don't know how people will get that out of it.
yeah, I mean we'd have to find a way to define what the identifier that you're giving means, and I think that may be the best we can do.
You typically have to identify the target of the attack, and the event should be about the target, which could be a more stable identifier than maybe the actor, which may pose different kinds of, they can be identified differently from time to time, right? So.
There is a spec like OpenID session management spec that is based on front channel iframes, which I think is going to be deprecated soon. But that gives if there are two relying parties, RP1 and RP2, the user is active in RP1, it keeps the RP2 session alive, send signals that RP2 to keep its session alive. So can we use this K to do the same thing through these signals? Is there a requirement is this something that we have to do it as a custom claim?
No, you can use the session revoked event just the way it is, right?
It starts session revoke, right? Session extend event, frankly.
Oh, you want to extend?
oh, so you're doing not the logout use case, the extension. Probably new event, yeah.
And something more about user activity, like this user invoked this particular task and event on this side.
Yeah, without digging deeper now, I think maybe the token claims change event could help with that, right? Because you could change any value that's in the ID token or the access token. Yeah. So that might be a way to convey that. But maybe it also would justify a new event. So we should definitely look at that if that's a use case you're looking at.
Okay. Just team off of it, I think what we're sort of asking is there a way to extend the kind of events, have your own custom events?
Yeah.
Basically, that's what it boils down to.
Yeah, so SSF does not, you're totally allowed to use custom events with SSF. We hope, though, that you will just come and we can just add it so that everyone can use them, right? That's why we want to make, like we said, we've been thinking about this for the past few years. We don't like that, just to add an event, you have to go through the OpenID 90-day review. We shouldn't have to do that. We have to find a better process. So we're working on getting a more registry-like approach where you could say, we have this use case, here's what it means. We think more than one company would benefit. Let's add it to the dictionary.
You and I may have talked about this, but what's the relationship? There was some thread relative to extending either SCIM or CAEP and REST. There were some tie-ins that you were looking at, right? Can you talk a little bit about that?
I think there is a draft called SCIM events that somehow leverages SSF. But it's currently just a draft, so I don't know what is the state. Maybe Nancy is here in the room. She's a co-chair of the SCIM group. She can maybe explain what the status is. But
yeah, my understanding is that draft would actually use SSF as part of protocol operation, which is a little bit different than what we're doing with the existing events we have, right? These are actually to communicate security events, whereas that's to actually to notify of a change at the protocol level for SCIM, they want to use this framework, which is totally allowed, right? That's totally extensible, yeah. Just different buckets. Oh, sorry.
yeah.
Is there a specific standard that defines that these are the assurance levels? Is there a format for that?
Yeah, the CAEP spec actually identifies certain assurance levels, but you can also extend it.
Yes, sorry, we missed you. Yeah. Yeah, so to answer the first question, yes, as we get further along with the spec process, we would love OpenID to help us build, as a foundation, build the conformance testing like we have for Connect and other things. That's certainly the plan. We just have to get past, there's some process gates we have to get through. We want SSF to get to it. Hopefully its final implementers draft this summer is the goal. The second one, so we are using it only internally. We are not exposing it externally today. So we have found great success. It is one of the core underlying things that makes CAE work. So
yeah. Just to answer the first one also, the protocol itself has good controls on who can subscribe to what, and there's a negotiation involved, right? You can say, I want to subscribe to all these events. The transmitters may say, I just don't trust you, right? And may reject that whole thing. Or the transmitter may say, well, you want all these events, but I'm only going to send you these few events, right?
I'm thinking of a scenario where the setup is established when the parties are in a clean state.
Right.
And then because there are so many applications, that application can have a vulnerability that could supply chain impact.
Right.
And cause poisoning now to huge identity providers, and it can get out of hand. So I was thinking of that.
That's a good point, and I think that's something we need to think about. Yeah.
Is the expectation that these streams are long-lived? I think you mentioned years in some of these use cases, but would it be appropriate for something like a session to actually subscribe to its own status at that point, so that if it were revoked, that would be returning, or would it be more appropriate to kind of proxy it through whatever service provider that was?
I mean, it's been designed to have a long life, but there's nothing in the spec that will prevent you from having a short-lived stream, right? But the good news is that for a long-lived stream, it has the controls to add and remove subjects. So you can say now the subject is added to the stream or it's been removed from the stream, right? So you may not need to do the stream setup every time, right? This.
Talk about the token change event.
Yeah.
The way I understand session is you're trying to get access to a resource or a set of resources. And you want access to them, which on the SD side you establish the session, right? And now on the ID side, you maybe remote access to a resource or the application. Would you think that case it makes sense to then send a session change event instead of a token change? I'm having a hard time understanding when you would use a token change event versus a session, because you want to notify the rest team that the session is no longer valid and they have a revocation on their side and reestablish the new session.
Yeah.
Can you repeat what she said?
Yeah, I think the question, and correct me if I'm wrong, the question is that when do we use a session revocation event versus a more general token claims change event? Because both seem to be affecting sort of the session, right? And I think the answer, the answer that I can think of is the session revocation event is a very specific event. You just want to, indicate that you've revoked the session and the recipient can do whatever they want with it. The token claims change event is a more generic event, right? So it can affect different things about the token, right? It could be specific claims that were included in the original token, new claims that you want to add to the token, or new values you want to give to the existing claims, right? And so all of the token we think is affecting the session itself, right? Which was established between the parties. So both these things are affecting the session in different ways.
Yeah, so like, for example, like for the transmitter, the transmitter may not have any policy around geolocation, but it may be passing it in the tokens that you as the receiver know, and you may want to know that changed, but we don't need to make you a new access token. Yeah. Okay. Right. Yeah. I think it's layers of detail. Right. So if you're like Azure AD, for example, is both a policy engine and an IDP, so they have a little bit more authority on the session, right? And whereas someone else may only have the context of a token claim. So I think I think the way I would have answered the question, actually, you answered it better in detail, but I think it really depends on your deployment, right? And that's, I think, the benefit of these. They mean what you want them to mean when you both agree on it, right? Yeah.
All right. Thank you,
Yeah, I
everyone.
think we're out of time.